So hi friends, welcome back to proton chemistry classes. In the last video I told you packing efficiency of solids, and so how to calculate packing efficiency. Already I told you packing efficiency equals to number of atoms, that is Z into 4 by 3 pi r cube upon a cube into 100. That is the formula to calculate the packing efficiency of unit cells. Okay. So to calculate packing efficiency of various unit cells, so we should calculate the number of atoms are present in various unit cells. So before going to this, means to calculate the number of atoms present in various unit cells, so we need to know the contribution of atoms at various positions. Okay, so before going to the calculation of number of atoms in various unit cells, so we need to know the contribution of atoms present at various positions in unit cells. Okay, so now let us start a contribution of atoms at various positions okay, in unit cell. Okay, so first one is at body center means the atom is present at center of the body. The atom is present at center of the body. So this is a simple unit cell, and this is what the center of the body. The atom is located at the center of the body. So the contribution of this atom per unit cell is 100%. 100%. The contribution of this atom at center of the body is 100% per unit cell. That means how many atoms are present at center of the body? Only one atom is present at center of the body. Okay, so what is the contribution of atom at body center? So that is 100%. That means it is equals to one atom, because only one atom is present at center of the body, isn't it? And the second one is at face center. At face center means the atoms are present at center of the face. The atom is located, or the atom is present at center of the face. For example, it is a face. The atom is present at center of this face. The atom is present at center of this face. So how many faces are over here? Total 6 faces are there. So the atoms are present at center of the faces. Okay, this is what center of the face. So this atom is present at center of the face. Okay, so this atom will be shared with 2 unit cells. Center of the body, the atom which is present at center of the face, shared with 2 unit cells. Hence contribution of this atom per unit cell is 50% per unit cell. 50% per unit cell? That means this atom is shared with 2 unit cells. So the center of the face atom is shared with 2 unit cells. Hence its contribution per unit cell is 1 by 2. That is 50%. So that means how many atoms? 1 by 2 atoms per unit cell. Okay, next, third one is at corners. Okay, means the atoms are present at corner positions. The atoms are located at corner positions. How many corners are over here? 8 corners are over here. So if the atom is present at corner position, so this atom will be shared with 8 unit cells. The corner atom shared with 8 unit cells. Hence its contribution per unit cell is 1 by 8. Isn't it now? Its contribution per unit cell is what? 1 by 8. Okay now. So that is 12.5 percentage. So that means it is 1 by 8 atom. That is equals to 1 by 8 atom. Isn't it? So because corner atom, each corner atom is shared with 8 unit cells. Isn't it? Hence its contribution per unit cell is what? 1 by 8. 1 by 8. Isn't it? Next, fourth one is at center of the edge. At edge center. At edge center. At edge center. Okay, means the atom is present at center of the edge. Okay, so this is edge of the unit cell. So if the atom is present at center of the edge, that is edge center atom. Okay, so this atom is shared with 4 unit cells. So how many unit cells are shared? So 4 unit cells are shared. Okay, this atom will be shared with 4 unit cells. Hence its contribution per unit cell is how much? 25 percentage. 25 percentage. That means 1 by 4 atoms. Okay, now 1 by 4 atom per unit cell, isn't it? So the edge center atom shared with 4 unit cells. Edge center atom shared with 4 unit cells, isn't it? So its contribution per unit cell is what? 1 by 4. 1 by 4. Okay, so this is the contribution of atoms at various positions of unit cells. Okay. So this is very useful for the calculation of number of atoms present in various unit cells. Got it? Next, calculation of number of atoms in various unit cells. Okay, first of all, number of atoms in simple cubic unit cell. So what is meant by simple cubic unit cell? So in this unit cell, the atoms are present at only corner positions. The atoms are present at only corner positions. Is called simple cubic unit cell. Okay, if atoms are located, if atoms are present at only corner positions, is called what? Simple cubic unit cell. Isn't it? So how many corners are over here now? Total 8 corners are over here. Okay, so if the atoms are present at only corner positions is called what? Simple cubic unit cell. Okay, so now the number of atoms equals to, so how many corners are over here now? 8 corners are over here. 8 into what is the contribution of corner atom per unit cell? 1 by 8. The contribution of corner atom per unit cell is what? 1 by 8. Isn't it? So that will be 1 atom. Okay, so 1 atom. So simple cubic unit cell contains how many atoms now? So 1 atom. That means where Z for simple cubic unit cell is what? 1. Okay, so in packing efficiency, so Z means what? Number of atoms. Number of atoms. So in simple cubic unit cell, how many atoms are present over here? 1 atom is present. So Z value is equals to 1. Right. Now second one is, so body centered cubic unit cell means what? Not is BCC, body centered cubic unit cell. In BCC unit cell means what? The atoms are present at corner positions. Atoms are present at corner positions besides center of the body. The atoms are present at corners of the unit cell besides the center of the body. One atom is present at center of the body. So this is called what? Body centered cubic unit cell. Okay, so the atoms are present at corner positions besides the center of the body. This is called what? Body centered cubic unit cell. Then the number of atoms at corners equals to, there are how many corners are over here? 8 corners. And what is the contribution of atom at corner position per unit cell? 1 by 8 equals to 1 atom. Then number of atoms at center of the body equals to 1. Okay, no? At center of the body, how many atoms are present at center of the body? 1 atom is present. 1 atom. So then total number of atoms in BCC unit cell is 1 plus 1 equals to 2 atoms. 2 atoms are present in BCC unit cell. Okay, next, third one is number of atoms in FCC. FCC means what? Face centered cubic unit cell. Number of atoms in FCC means what? Face centered cubic unit cell. Face centered cubic unit cell. Okay, so face centered cubic unit cell means what? If atoms are present at corner positions besides the atoms are present at center of the faces. So how many faces are present in simple cubic? 6 faces. There are 6 faces are present. Upward face, downward face, right side face, left side face, and this total 6 faces are present, isn't it? So then the number of atoms at a center of face equals to, there are 6 faces, 6 into, what is the contribution of atom at center of the face? 1 by 2, because this face center atom is shared with it will be shared with 2 unit cells, hence contribution of this atom per unit cell is what? 1 by 2, that is equals to 3 atoms. Then number of atoms at corners equals to, there are 8 corners and contribution of atom at corner position per unit cell is 1 by 8, that is equals to 1 atom. Then total number of atoms equals to 3 plus 1 equals to 4 atoms are present in FCC. So for FCC face centered cubic unit cell, Z value is what? 4. Means 4 atoms are present in face centered cubic unit cell. Okay, so these are the number of atoms present in various unit cells. So then packing efficiency of simple cubic unit cell equals to 52% and void means vacancy equals to 48%. Okay, next, packing efficiency of body centered cubic unit cell equals to 68% and void equals to, void means vacancy equals to 32%. Next, in packing efficiency of face center cubic unit cell is equals to 74% and void or vacancy is equals to 26%. Okay, mean packing efficiency of simple cubic unit cell is 52%, void or vacancy is 48%. Means in simple cubic unit cell contains only one atom. So one atom occupies how much volume percentage? 52% of volume. Okay, the volume covered by the atoms in one unit cell is called packing fraction and the percentage is called packing efficiency. The percentage of volume covered by all atoms in one unit cell is called what? Packing efficiency. So the packing efficiency of simple cubic unit cell is 52% and void or vacancy is 48%. And packing efficiency of body centered cubic unit cell is 68% and void or vacancy is 32%. Means the body centered cubic unit cell contains two atoms. So two atoms occupy 68% volume, isn't it? Hence its packing efficiency is 68. And packing efficiency of face centered cubic unit cell is 74% and void or vacancy is 26%. Means so face centered cubic unit cell contains how many atoms? 4 atoms. So 4 atoms occupies how much volume percentage? 74% volume. So 4 atoms occupy 74% volume in face centered cubic unit cell. Hence its packing efficiency is 74% and void or vacancy is 26%. If the number of atoms increases, packing efficiency is also increases. For simple cubic unit cell, Z value is what now? 1. Means what? How many atoms are present in simple cubic unit cell? Only one atom is present. In BCC, Z value is what? In body centered cubic unit cell, Z value is 2. That means the number of atoms present in BCC is what? 2. And the number of atoms present in FCC, that means Z value is what? 4. Z means what? Number of atoms. So face centered cubic unit cell contains 4 atoms. Okay, if the number of atoms increases, the volume percentage is also increases. Okay, that means the packing efficiency is also increases. Okay, so this is packing efficiency of solids. Okay.